Hi everyone, welcome to A Coding Group. Today's topic is the optimal degree of parallelism. My name is Tom Liao. I'm the speaker of this channel. Here's the scenario of today's topic. Recently, one of my friends got an assignment. His company wanted him to create a system that could manage a large volume of file backup. His company already has a commercial backup system running, but that's pretty much a standalone product which cannot talk to the cloud service that they have created. Customization of that third-party system costs a lot. Therefore, they decided to make their own backup system. Long story short, he needs to create an application that can handle at least 1 million folders and 5 million files. And he realized that he needed to run such tasks in parallel. Therefore, he has tried these 3 parallel iteration statements: parallel for each, and parallel for each async, to see which one yields the best result. However, no matter which one he used, he ended up in the same situation. At some point, the application started running slow. By observing the system information, the memory was occupied 75%. Disk I/O was at almost 100%, but the CPU usage was relatively low, only at around 40%, sometimes even dropping to 20%. He wondered why was the usage rate of CPU so low. In order to make the CPU work harder, he set the parameter max degree of parallelism of the parallel options to -1. According to the C# language reference, if we set max degree of parallelism to -1, then the system will start as many threads as possible to complete all tasks required. But obviously, the -1 didn't provide the desired result. Then what will be the most optimal value of this option? If a process needs to complete 1 million tasks, then will it help if setting that number to 1000? Or should that number go higher or lower? There are lots of factors we must consider, such as whether those tasks are CPU bound or I/O bound. Are they long-running tasks, or they will be completed within a short period of time? How about the memory consumption? Where are those jobs done? On the system disk? On different disks of the same machine? Are the whole processes done over the local area network or over the internet? Is there any other process running on the same system that's running your application? There are lots to consider. Let's simplify the considerations. The most important consideration is whether it's CPU bound or I/O bound. If it's CPU bound, such as doing AI algorithm computing, it might yield high CPU usage. If you let the max degree of parallelism to be -1, then too many threads are waiting for the CPU to be released to do the next task. It slows down the performance. If it's I/O bound, such as reading and writing disk files, the CPU usage might be low, but too many threads occupy too much memory resource as well as generate too many disk I/Os, then again, it slows down the performance. Obviously, too many cooks spoiled the broth. Then back to the question, how exactly can we define a suitable number for this setting? Well, usually, not always, and it's based on my real-world experience. We set it as a logic processor count -1. If you have one physical processor with 8 logical cores, then we set it as 7. Why -1? Because we reserve 1 core for the system to do other jobs. Don't let other jobs cause impacts to our job. If you search this topic online, you may find some people suggest setting it as logic processor count +1. I think that's probably because the hardware was different. Due to my own experience, -1, sometimes even -2, provide the best performance. Actually, we can also limit the usage percentage of CPU consumption, such as limiting the process to use no more than 70% of the CPU. However, that is only effective for CPU-bound tasks. Okay, this is today's topic. Hope you like it. This issue also inspires me for the subject of my next Udemy course. Please stay tuned to this channel. I'll inform you when the course is available.